4a. We got cosines and sines. So let's remember the identity that we often use. Sine squared x plus cosine squared x equals 1 when we have integrals that have both sine and cosine in them. That's sometimes what we use. So I am going to pull off one cosine because we have an odd cosine here. So it's going to be cosine to the 4th x and then cosine x dx. That's going to be reserved for my du here in a minute, over the square root of sine x. Now I'm also using, so if I replace, so cosine squared x is equal to 1 minus sine squared, which means cosine to the 4th is 1 minus sine squared x squared. And then we still have our square root of sine x down here on the bottom and cosine x dx. Now we're ready to make a u substitution. So we're going to let u be sine x, in which case du is cosine x dx. That's why we reserved it. All right, and so now we have, I'm going to expand this top, so that's 1 minus 2 sine squared x plus sine to the 4th x, and I'm going to write the square root of sine x as sine x to the 1/2. And then we have our cosine x dx. So we're replacing all this with u. We have 1 minus 2u squared plus u to the 4th over u to the 1/2 du. It's all coming together nicely. And now we're going to divide that u to the 1/2 into each term. So we now have u to the negative 1/2 minus 2u to the 3/2 plus u to the, what is that, 7/2? 8/2 minus 1/2 is 7/2. That's good. Du. And now it's just a power rule. Pretty straightforward. So it's going to be u to the 1/2 over 1/2. So 2 minus 2u to the 5/2 times 2/5 plus u to the 9/2 times 2/9, of course, plus c. And let's clean it up a little bit and replace our u with our original. So 2 sine x, I'll write it this way, to the 1/2 minus 4/5 sine of x to the 5/2 plus 2/9 sine of x to the 9/2. Woo-hoo-hoo-hoo, plus c. Not too bad.